क्वेश्चन का क्या है?
अभी लगता है
क्या करके आया भाई? फिर वापस पोजीशन हमें को ब्रेक करना है
अभी
मीटलेस का नहीं अभी नहीं
तो ब्रेक कर दिया
10 मिनट नहीं वापस मेरे साथ
Sunday it's a meatless day.
20 तक तब
Meatless day. 26 of November था.
बहुत ठंडी
गरम हो रहा है
अमृतसर में बहुत ठंडी रहती है
अमृतसर में ठंडी
अरे 26 to 29 अमृतसर जाना वो हमारी ट्रिप है
अभी तो ठंडी
तो अभी क्यों ठंडी ठंडी लग रहा है
नहीं मतलब ट्राई आउट कर रहा हूं
स्कूल बनना है ना स्कूल अच्छा
नहीं यार मुझे बना सकता
अरे पसीना आ रहा है भाई
कोई यूनिफॉर्म छुपाने की
ये भाई को चल बताओ चल बताओ
इतना फ्लेक्स किस लिए करता है
यार देखिए
तो इतना फ्लेक्स क्यों करता है
ये तो नहीं करता
क्या करना है अंदर वो छोकरियों वाला रुमाल का पॉकेट है इंटेंशनली ना बट आंटी ये गलती से था
आंटी ने क्या किया
आंटी ने बोला कुछ नहीं बेटा रात को घर आ जाना बस एड्रेस दे दी
तो बाद में आपने बोल दिया आंटी ने कुछ नहीं किया
आंटी ने वो क्या किया
पीछे से क्या हुआ
ऐसा लाइट नहीं किया
तू ऐसा किया
ऐसा हाथ आगे गया और ऐसा तो गलती से मैंने आप उसको बताया मैंने
तो हमेशा का क्या किया
वो गलती से था चलते चलते अर्नब को बताया मैं अर्नब
Sir, actually, I want to talk with Rekha ma'am regarding something.
Regarding our exams.
So what were you doing till now?
She showed me the parents.
Will take more time?
No, ma'am,
No, no.
2 minutes.
2 minutes, okay. Go.
Sorry.
What is it?
You spoke with Rekha. Yeah, मतलब तुम्हारा बात हो गया.
एडमिशन के लिए आना था खाली चेक साइन करके
Still talking with the ma'am.
What is it like? You have to.
we are having our exams and we are not going to come from
So you can communicate after the class also. Or during the class, one of you can go and. Are we expecting more kids? More students?
Many of them are thinking that it's 5:40.
Oh, is it?
Yeah.
Acha, it's extra class. Last time also somebody missed.
हाँ,
You had
I
missed.
missed.
520 earlier period 520
So they are not checking the timetable.
it's not like that
Please check your timetable because now since 10 students lectures are completed, so we have extra hours remaining. So there may be change of schedule for you people. Okay, so keep a tab of your timetable before coming. 1 day before at least. You know? Okay. Okay, tell me, where were we? You are doing sound?
sound yes.
Yes.
What in
You
sound?
had the last one of the sound
Okay, the heat chapter we have skipped right now.
No, heat is that
Heat is
part of
complete.
heat.
Acha, 8 is already completed.
This intrasonic humans ultrasonic
Okay.
large paper.
The lens part we have completed, right? Lens, the optics,
Yes.
reflection of light all over खत्म हो गया. What is remaining? Sound, which one? Last part? Did we do numericals in this? We had to do the numericals, right?
Yes, infrasonic and ultrasonic frequencies.
So we have completed infrasonic and ultrasonic. We have to now start with ultrasound and its applications, right? So ultrasound and its applications.
यहाँ तक कि short review ही है.
These are the complete करेंगे. तो short में भी हुई.
अब इधर
वैसे नहीं करना
ये चला जरा वो
राउंड लाया
वही है. मिडिल की 33 की पीछे है. लाया.
day of present but present के बेटे
लाया. वापस नहीं ले.
Ultrasound and its application. So we learned in the last class what is ultrasound. These are the sound waves with highest frequency, right? Ultrasound waves have maximum frequency of and hence are most energetic. Okay, so among all the sound waves, ultrasound waves are most energetic because they have maximum frequency, and due to that, therefore, ultrasound waves can travel large distances can travel large distances without much deviation. Without much deviation.
Yes.
Without much deviation. Okay. So this is the property of ultrasound wave. It has maximum energy as well as, and because of that, it can travel large distances without much bending. Hence, it finds many applications. So, due to above property, of ultrasound waves, It has many applications. Okay, so there are some 6-7 applications we can discuss one by one. So bats use ultrasound waves for navigation and ranging. Bats produce and transmit ultrasound waves for judging the safe direction travel and for judging. So this is called navigation. Direction is navigation. For judging the distance of obstacle. This is called ranging. Okay, so what bat can do? Let us say you have a bat here. So if it sends ultrasound wave everywhere, so from the obstacle, when the reflected echo comes back. So depending upon what information the reflected ultrasound wave carries, bat will be able to judge whether it is safe to fly in this direction or not. So the estimation of distance or judging of
detecting other birds also.
bugs also, yeah. So this is sending waves in all directions. So if there is it can also detect the prey. Okay. So depending upon what is the nature of the reflected sound wave, it will know whether it is threat or
Bats are blind, right?
yes.
That's why they use.
That's why they use indirect method. Okay. So echo. So from the echoed ultrasound wave, they
So
will.
for them, their brain perceives that as.
Hmm?
So for them, their brain perceives the
Yes.
sound.
Yes. So this is like navigation. This is not the safe direction to travel. So they will change the direction. And this is estimation of distance of prey. Okay. So they will either fly fast or slow down if it is a threat. Okay. So this safe directions to travel is called navigation. And this is called ranging, estimation of distance. Okay. This is called sonar also. Sonar, sound navigation and ranging.
Yes.
This is called sonar.
It is used in submarine.
Everywhere, even this, what they are doing is sonar. So when humans use it, it is called sonar. Right? Sound navigation and ranging.
अल्ट्रासाउंड का भी स्पीड सेम ही होगा साउंड के
Same. Just the frequency is more. So it is more energetic. Like when we are speaking, again, since we have less energy, तो ज़्यादा दूर जाएगा नहीं. I mean, a person standing across the road may not be able to listen to us. Okay, but if he is holding an ultrasound detector, we send ultrasound from here, he will get it. That's what it is. So that was first use. Second, you can read it yourself wherever you feel the need for me to explain, I'll explain. Just read it yourself, pretty self-explanatory. Second is, it is used for drilling or making holes. Okay, drilling holes or making cuts of desired shapes in material like glass. Second application is used for drilling holes. Or making cuts of desired shapes. Desired shapes in materials like glass. So you have it in your book, materials like glass. Okay, so ultrasound is a wave, so if we drill it using a metallic bit, it might break the glass. It's safer to drill it with the elbow. So gentle vibrations and it will peel off, the glass from where we don't want it, or where we want to make it a cut. Third, it is also used for cleaning minute objects. For cleaning minute objects. What kind of minute objects? Such as parts of watches, electronic components, right? Such as parts of watches, electronic components. Okay. So basically, what you do is you have a soapy solution. Okay. Or a detergent solution. In this, the components are kept. Okay, small components are kept. And then the ultrasound waves are passed through the soapy solution. So that will vibrate, which will detach the dirt of these components. Okay? This is how it is. Soapy solution where you can put the components, then pass ultrasound waves. Due to vibration, the dust will get detached. Dust is clogged on. That's chemical reaction, right? Chemical reaction.
But won't it damage the electronics?
No. I mean, just the dust. It will react only with the dust, not with the electronics. You mean short circuit, etc.
Yes.
So the electronic components are coated. Okay. So it won't reach till there. But all the other things it will remove. Like if your PC maintenance guy, it comes with a blower, etc. Right? I mean, you can't sometimes wash or brush it, right? So you blow it off. Okay, something like that. But sometimes in blowing it off, there may be a static energy. Electric static energy is there. So that may destroy the components. Okay, so these are there are some other processes. There are various processes. It won't conduct electricity, not that high potential difference. Okay. So that's what it is. So let's put cleaning solution. It is not soapy, so it's taken care of. Cleaning solution. Or that depends on certain salts that are electrolyte. So it should not be electrolyte.
You can also do it with like distilled water.
You can, yes.
But distilled water would wash away the dirt.
What is washing away the dirt is the ultrasound vibration, not even the soapy solution. So, like you have a washing machine, it has a soapy solution, but when you turn it, it is thrashed. So the thrashing is needed. That thrashing is provided by vibrations of ultrasound. That's what it is. Then fourth point is detection of defects in metals. Now this is interesting. How do you detect defects in metals? So any idea? So there is detecting. Defects in. So how do you detect defects in metal? देखो क्या होता है? Suppose you have a metal block, right? So the block may seem very perfect from the outside. You don't know whether inside there is a cavity or imperfection. There may be a cavity inside. So you can't use such a block when you're constructing bridges or building high-rise buildings. So yes. What happened? You forgot the time.
When I checked the timetable late,
Did you get a call from UT? No. So let's say this is a metal block with a cavity inside. Okay. So if there is no cavity, the ultrasound wave will pass through the block without any trouble. But wherever there is a cavity, it will reflect the ultrasound back. So let us say you have a ultrasound transmitter. Okay. So you have a and you have some ultrasound detectors here. So 1, 2 are detected and the third is not detected. So what will happen? This imperfection will reflect the sound back. So there are 3 transmitters, let us say. Okay. 3 transmitters and 3 receivers. But only 2 are received, although 3 are sent. That means this block is not usable. Okay, this is a metal block. With some deformation, some imperfection, which is shown as a cavity here. Understood? So you can't use this block, not advised. This is how you can figure out crack in the pipe or some welding if it is not perfect. It can be detected by passing ultrasound waves through the metallic block. Okay. So for imaging the human organs, it can. So you must have heard about ultrasonography. is used for imaging human organs? Ultrasonography. Heard about it?
What of this sonography? What is this?
Sonography is ultrasonography. It uses ultrasound waves.
So
Yes. Okay. So sonography is nothing but ultrasonography. It is used for imaging. Used for imaging internal human organs. Organs such as liver, kidney, uterus, etc. Okay, so this is what it is used for. It can also be used to check the status of fetus. Check the growth status. Fetus. Is this spelling correct? Fetus?
Yes, F-O-E-T-U-S.
Fetus. Okay. And here you have gallbladder also. Gallbladder. So what it does is the ultrasound waves are sent on the patient. Ultrasound wave is sent on the patient, and the reflected ultrasound waves from the organs, right? So we already have the images of reflected sound wave from the healthy humans. Okay, so we can compare. Then we can come to conclusion whether the organ is at fault. Okay, so it is by comparison. So to check the growth status of fetus also we do. So the reflected sound wave is electronically processed and the image is generated on the computer. That's what happens. Then specifically if the imaging of heart is to be done by using ultrasound waves, it is called echocardiography. Okay. So echocardiography is the technique for heart imaging using ultrasound waves. So since is you have echocardiography. Heart imaging. Ultrasound. Used for heart imaging. Then how come my sixth point is
So here ultrasonography and echocardiography are the same codes.
is it?
Yes.
That's right. Okay. Next is what is next? It can be used for surgery. Used. Ultrasound wave is used. I'm not writing ultrasound. These are all uses of ultrasound only. So for surgery of kidney stones. kidney stone. Surgery in the sense, surgery to remove cataract and stones from kidney. Used in surgery to remove cataract from eye. What is cataract? What is cataract?
It's not accumulation of
Opaque substance, right? Milky. You can see the eye turns milky. The eyelets turns milky. It's a coating, right? Above the lens. So which will create a blurred vision. So you can remove it and to break kidney stones. So kidney stones can be broken into small granules which can come out along with urine. Into small granules that can flush out with urine. Okay, so there may be like deposit of like crystallized deposits in the kidney, which are called kidney stone. Okay, so that can be broken into small pieces, which can then flow out with the urine. Then last, it is also used in sonar devices. Used in sonar devices. Sonar devices. ठीक है? To judge the distance of threat, distance of obstacle, and to navigate into safe direction. Okay? Using sonar devices for navigation and ranging. What is the meaning of ranging? What is the meaning of ranging?
to find the distance between
Yes.
two.
Estimation of distance of obstacle. Like iceberg, in case of ship, when it is traveling through the sea, and the captain spots the tip of the iceberg. But the tip of the iceberg looks very small and it's very deceiving. So captain may think I'll slightly avoid the iceberg and pass on. But iceberg, only a small portion is visible above. The large, more than 90% of the iceberg is underwater. So it may be a disguise. Captain may feel it is little safe to just avoid by 5 meter, 10 meter. And it may hit the iceberg, the propeller may get entangled with the iceberg. Okay, which may cause damage to the ship. Right? So such things. So then you send sonar waves everywhere. Sonar waves, ultrasound waves can travel in all directions and through all mediums. So from the nature of the reflected waves, it will come to know at what distance is the obstacle. Then you can calculate and decide about navigation. Such things. Difference between ultrasound. You got a call from UT? Then you're not aware of the. Achha. Okay. Many of you are not aware about the change time, so please keep a tab on the timetable. You may witness more changes. Okay. So keep a tab on the timetable. Difference between ultrasonic and supersonic. Okay. Any idea what is ultrasonic and supersonic?
Ultrasonic frequency is higher than normal sound. Oh.
So ultrasonic is the normal sound wave, which travels with what speed? Up to 330 meter per second or 340 meter per second. This is the speed of sound. Okay. Now, so any sound producing object such as aeroplane, it produces a loud sound. If that object itself travels with the speed greater than the speed of sound, okay, and that object is termed as supersonic object. Like a fighter jet, they travel with the speed of about 1000 meter per second. So 1000 is easily Mach 2. This is called Mach. Speed of sound is called Mach. So this is Mach 1. Any object traveling till this speed is Mach 1. Okay. So then what happens with supersonic objects? Like I gave you the example of fighter jet. The moment it crosses this speed, it sends shock waves, which is called sonic boom, which is a unbearable sound actually, very loud sound, unbearable to such an extent that the glasses may crack. Okay.
Can I hear from the
Yes, you may go deep temporarily till it revives on its own. And in some cases, it may be a permanent damage. So that's why you must have seen people who assist pilots to park the plane, right? So they wear protective ear gear. So they have that. Even the pilots who fly the plane, they have a protective ear. Okay? Because the sound is just unbearable, right? So you understand? So Mach 1 is any plane flying around 330 meter per second. So this is called Mach 1. Planes have speed Mach 1, Mach 2, Mach 3, very normal. Understood? So supersonic jets, there are supersonic jets. Send shock waves or also called sonic boom. So sound, the sound of the explosion is sonic boom due to sound wave. Okay, or sonic boom. And when the speed exceeds the speed of sound. Okay. So have you understood the difference? The sound producing object itself is traveling with a speed larger than the speed of sound. Then it produces sonic boom, which is a unbearable sound. So you must have heard about Concorde jets.
Yes.
So there was a plane, Concorde jet, which was flown between India and Australia. Was it between India and Australia?
stars?
Transatlantic routes.
So it was then discontinued. Like it suffered an accident.
Because of a crash.
Yes, it got crashed. Okay, and so it was discontinued. When was that? Anybody remembers?
19
It's discontinued. There might be some Discovery series on that. Have you seen a Discovery series on that?
I've seen not a series on it, but it was an episode of
Disasters. Disasters. Episode of fatal crashes or something like that.
no, it was Mythbusters. Have you seen that?
Huh?
Mythbusters. Have you seen that?
Big?
Mythbusters.
Mythbusters. What is it? Animation?
No. These are two scientists and they bust myths from science.
So, तुमने कम बोल दी ना TV series.
Yeah. No. That's a TV series.
Mythbusters is a series. Okay. So I hope you got the idea about what are ultrasound waves and what they are used for. Now let us quickly do the numericals. Have we done the numericals or we did not do the numericals? Okay. So here we should be able to. Let's do the numericals of unit A. You don't have numericals in unit B. Do we? There are no numericals in unit. Okay. So what are the formulas to be used in this chapter? Speed is distance upon time. This is one. Also speed is frequency into wavelength. Frequency into wavelength. So what is this speed? Speed of the object in terms of distance traveled and time taken. This is speed of wave, right? And also we have v is equal to 2d by t.
So what is it?
Frequency. So what is it? This is the distance of the obstacle during echo. This speed is speed of sound. V is N2. And what is 2d? Distance traveled.
Because you counted is
It covers 2 times the distance, incident and reflected. Okay. And there is one more formula here for time between time period and frequency. T is equal to 1.9. That's it. So using these formulas, you should be able to tackle all the numericals. So how many formulas are there total? 1, 4. There are 4 formulas. Okay. So there are 11 questions. Let's do alternately. Which one you want me to do? Order even.
So or ज़्यादा क्वेश्चन देखो कम करना है ये सर
Yeah, so what is first question? The heart of a man beats 75 times a minute. What is its frequency and what is the time period? So, what is the meaning of frequency? Number of time heart beats in 1 second. So, in a minute, in 60 seconds, okay, heart beats 75 times. Okay, therefore in 1 second, in 1 second, how much it is? 75 by 60 times. So this is nothing but frequency, right? Therefore, frequency is 75 by 60 hertz. So find out how much is this. This is 7.5 divided by 6. This we have 12. 31.25 per second. Per second or hertz.
So both is okay, right? If I write hertz, it's okay.
Yes, that is the unit.
No, here it's given S minus 1.
S minus 1 is per second. No?
Per second.
Divided by 75 is the number. Divided by time. So 1 by time is per second, which is nothing but called as hertz in his honor. So that's frequency. So what is time period? 1 upon f. T is equal to 1 by f. What is 1 by f? So this is 1 by 1.25, which is 100 by 125, which is 4 by 5, which is 0.8 second. Okay? 4 by 5 is 0.8 second. That's the answer. So question 3, what is given in question 3? The separation between two consecutive crests in a transverse wave is 100 meter, which means what is given? Wavelength is given. Crest is the peak of the wave in case of a transverse wave. This is in case of transverse wave, the peaks are called crest. Whereas in case of longitudinal wave, the peaks are called compression.
It will be wavelength, right?
This is obviously. So you have to remember is crest is in case of transverse wave, and in case of longitudinal wave, it is called compression. So this is given as, how much it is given as? This is crest. And what is the valley? Valley is called trough. Okay, so the consecutive distance between trough also is a wavelength. Okay, and the distance traveled during one wave cycle is also a wavelength. There are 3 ways to define a wavelength. This also is a wavelength. Oh, we have to distance traveled by the wave in one wave cycle. Okay. So what is given in the question? Given is the speed of the wave is given to you. Sorry, what is given to you? Yeah, speed is given and wavelength is given. Given V is equal to 20 meter per second. And wavelength is 100 meter. 100 meter. What you are supposed to find out is frequency. Find the frequency. So what is frequency? V by lambda. Since V is equal to F lambda, F is equal to V by lambda. What is V? 20 divided by 100. 0.2 hertz. Question 5. What is given in question 5? "40 crest and 40 troughs in how many? In 0.4 second. That means one crest and one trough is one cycle. That means it is producing 40 waves in 0.4 second. So then what you are supposed to find? What is the frequency? Frequency is number of waves in 1 second. So what is given is in 0.4 seconds, right? So 40 waves, wave cycles. One crest and one trough is one wave cycle, or one vibration, or one oscillation. Therefore, 1 second is 1 second. Number of waves is equal to 40 by 0.2. Okay? Which is nothing but frequency. Frequency is number of waves in 1 second. So which is equal to 100. 400 by 4. Therefore, F is equal to 100 hertz. Get the logic of the question. 0.4 second corresponds to 40 crest and 40 troughs. So it's not that 40 crest will happen separately. Against every crest, you'll have a trough. So it is alternate, crest, trough, crest, trough, crest, trough. So 40 of those are taking place in 0.4 second. So in 1 second, how much it will be? 400. That's the frequency. Okay? Because by definition, frequency is number of waves produced in 1 second. 7. What is question 7? So time interval between a lightning flash and first sound of thunder is 5 seconds. If the speed of sound in air is 330, find the distance of flash from the observer. Right? So sound time is given as 5 seconds. Speed of sound is given as 330. So which formula to use? You have to find the distance of the source. That is, you have to find S. Okay, S. So B and T is given to you. So since V is equal to S upon T, this means S is equal to V into T. V given in the question is 330. 330 into 5.
165. Divided
Why divided by 2? It's coming one way only, it's not echo.
but oh, we have to answer.
Okay? It is the sound of the thunder. So it is not echo. Alright. 9. An observer is sitting in line of 2 tanks. Watches the flashes of 2 tanks firing at each other at the same time. But he hears the sound of 2 shots, 2 seconds and 3.5 seconds after seeing the flashes. If the distance between the 2 tanks is 510 meters, find the speed of sound. Okay, so it's like this. Can you visualize the question?
Yes.
So there is one tank and this is another tank. So there is some observer sitting in the line of tank. So let's say this is S1, this is S2. So he hears S1. Which one will be heard faster when he hears? Yes. What is the distance between the tanks? 510 meters. So this is, let's take the distance from here. This is 510.
So I thought you were starting between the two times. Like one time on this side, one time on that side.
No.
Then he will die. He is standing, sitting in the line of the tanks. Right? Then you have, isn't it? Standing in the line of the tank.
Yes, yes.
Only then is it said that he is sitting between the tanks?
No, no.
Sitting in the line of two tanks. So S2 will be S1 plus 510.
But if that was there, then you wouldn't calculate it,
Then you can still calculate. You need to know the distance, right? So that's one. Okay. So what is to be estimated? What is to be estimated? Find the speed of sound. So you have to find the speed of sound. V is equal to 1. Okay. So what is given here is T2 is given as how many? 3.5. 3.5 seconds. And T1 is? T1 is 2 seconds. Okay. Again, we'll use the same formula V equal to S by T, right? So and V is also equal to S1 plus 500. Right? So you can eliminate S1. This is S1 is equal to VT1. So this is like VT2. S1 plus 500. So S1 is VT1. So therefore V T2 minus T1 equal to 500. So for V is equal to T2 minus T1. This is what we get. 510 divided by T2 is 3.5 minus 2. 510 divided by 1.5. This is 5100 divided by 3. Find out how much is this. That many meters per second.
340.
Coming 340?
Yes.
Excellent. So this is 340 meters. You got the logic? How I did it?
Yes.
So to visualize the situation, then simple formula substitution. So with this, we come to the last question, and I'll give you the clue for that. You have 2 lectures now, maths after this. So assuming the speed of sound in air is equal to 340 and water is equal to this, find the time taken to travel the distance of 1700 meters by sound in air and water. So since V is equal to S by T, therefore S is equal to V into T. So first S air will be V air into T air. B you have to find as water, B in water, into time in water. Okay. So in the question, you are provided with two mediums, and the sound in different medium is given to you. So this is 340. Time it takes in here is, oh, the distance is given, sorry. My bad. You have to find the time. Distance upon distance is given as 1700 for both cases. Here is 340, and here also the time taken in air is equal to this. Time taken in water, how much? S water upon V water. How much is that? 1700. This is 1360. So this you should get as 5 seconds.
5 seconds.
This you should get as 1.25 seconds. Okay. So some simple questions, and the rest you should be able to do yourself. I feel sorry for those who missed the lecture. So you got to help them, or they can see the video.
Finally, you are congress.
25th of December.
November, it's a date you remember?
28 hours.